Hello, my name is Waverly, and today I'll be going over the CAD and the systems of an FRC robot. For this, I'll be looking at Team Viperbot's Valor, based out of Vandegrift High School in Austin, Texas. This team, number 6800, has been a member of FIRST since 2018. I will be looking at the robot that they created for the 2021 FRC game, Rapid React. In Rapid React, teams had to collect oversized tennis balls, called cargo, and score them into the lower and upper cargo hubs. At the end of the game, robots must climb up bars that become increasingly higher. Team 6800's robot, Diablo, finished the season with 62 wins, 12 losses in official play, and 77 wins, 19 losses overall. They were ranked first in their district, first in Texas, and were the event winners. I will be exploring this robot's CAD model and explaining how it works. This robot's CAD model and explaining how it works. The first subsystem I want to look at is the chassis. To take a closer look at it, I'm going to hide the other subsystems for now. This robot is 26 inches by 26 inches without the bumper, and 33.25 inches by 33.25 inches with it. This robot, Diablo, utilizes a swerve train drivetrain and is driven by SDS MK4 swerve modules, each of which is powered by two Falcon 500s. Attached here is the main circuit breaker, so it is easily accessible. Next to the breaker switch is the battery, which fits right into this compartment and plugs in to the Anderson connector here. Now, while looking at the chassis, I want to draw your attention to these three plates, called the motor shrouds and the lift shroud. These plates protect the important parts of the robot during a game to ensure that nothing gets broken. Look at the main electrical components of this robot. We've already seen where the battery goes and the slot in the bottom of the robot. The other primary electrical pieces are all grouped together on a single plate. This plate can easily be taken in and out of the robot, so that Team 6800's programming team is able to work in prototype code at the same time as their assembly team continues building the actual robot. On this electrical power panel is the Robo-Rio, the power distribution hub, the Raspberry Pi, the network switch, and the radio power module. All of these components are right here on this panel. Viperbot's Valor says that this system of organizing electronics is the most efficient way of working on the robot that they have found, and they plan to continue using this model as long as they can. Valor with a ground intake system. This mechanism is made up of 3 rollers, all of which direct the cargo back into the robot and into the feeder. In order to get to the feeder, the cargo has to roll up and over the bumper. So Team 6800 used cat's tongue tape in order to increase the friction and compression. This intake is also made to pull back into the robot at the beginning of the match and extend out when it is time to begin intaking cargo. Team 6800 said that they want a rigid, compliant design so they can move the cargo around without worrying about anything getting stuck. The 3 rollers are powered by a Falcon 500 at a 4/3 gear reduction. Another interesting part of this robot can be found in the software. The limit on the number of cargo that can be in that a robot can get in control of is 2. So to prevent penalties from accidentally leaving their intake running while holding 2 cargo already, the team placed sensors onto the robot in order to detect how many balls have entered it and how many have left. If there are 2 balls in the robot already, it is unable to continue untaking, preventing from risking any unnecessary penalties. It's a fairly basic indexing system. Once the cargo goes over the bumper, it is led into the indexer by several plates around the entrance to the feeder. These plates funnel the cargo into the indexer so they can be fed up into the turret. The indexer is made of 2 rollers that spin in opposite directions on either side of the cargo, with 2 polycarbonate rails meant to guide the cargo up through the middle of the system. A small amount of cat's tongue tape is used on these rails to maintain ball control and compression. An interesting software feature can be noted if we look at this sensor. This sensor can see whether or not there is a ball in the indexer and will help decide whether to continue intaking or not as a result of this information. I had one goal in mind while designing the shooter for Diablo, to be able to shoot into the upper hub from any position or location on the field. To do this, they would need to be able to face the hubs and have the correct angle for ensuring that it was shot directly into it. This first problem is one that many teams ran into during the building process. Many of the teams decided to either turn the shooter into a revolving turret and use tank drive, which was a much more popular drivetrain system at the time, or make a stationary shooter on top of a swerve drive drivetrain. Both of these methods work well in theory, but Viperbot's Valor decided to do both of them. As I have previously mentioned, Diablo has a swerve drivetrain. However, Diablo also has a turret. Viperbot's Valor said they made this choice because they wanted to do predictive shooting and be able to deal with defense more easily than a robot with a tank drive would be able to do. This turret has 180 degrees of motion, making it incredibly good at accurate shooting. The shooter mechanism consists of one 4-inch diameter neoprene roller on the front and two 2-inch diameter top rollers in order to cut back on backspin. The flywheel is powered by a Falcon 500 at a 1-to-1 ratio. In order to solve the second issue that I mentioned, or be able to obtain the correct angle, the hood of this turret is adjustable. The continuously variable hood has 24 degrees of motion, ensuring the cargo can be shot into the hub from any distance away. Powered by a single Neo 550, the hood uses a limelight sensor over the hood in order to have the turret continuously pointed at the hub, both at the correct horizontal positioning and at the height needed. A robot has to climb a series of bars that get increasingly higher in the air. In order to do this, Viperbot Valor built a 2-stage climbing system. The first stage is stationary and consists of 2 bars with ratcheting hooks on top of them. These are connected to the back bar of the robot. The second stage of this robot, a dynamic stage with a fixed hook that can move both vertically and horizontally, is what pulls the robot up to the bars. It climbs straight up to the first bar, where it latches on and pulls itself down. The ratcheting hooks here will lock onto the bar. Next, this dynamic bar will go back, up, and hook around a bar that is up in the air behind it. It once again will pull itself in, where the ratcheting hooks will lock into place. Diablo will repeat this process until it is on the bar of its choosing. This dynamic stage is powered by 2 Falcon 500 with a 6-to-1 gear reduction. There is only one gearbox, which Team 6800 says was very important in order to keep the climber compact. In the first iteration of this robot, the stationary stages were connected to only the back bar, which put a lot of stress on it. In order to resolve this issue, the team installed tie rods on either side that bolt into the center of the robot, distributing the robot's overall weight much more evenly. Team 6800's robot, Diablo, is a very interesting mix of innovative and basic parts. They did a good job of following the KISS principle and kept it simple in all areas that they could. The shooter and the climber are the 2 parts that I find the most interesting. Viperbot's Valor combined 2 popular ideas at the time, turret with tank and shooter with swerve, and used the better parts of each of them, resulting in a shooter with high accuracy from any part of the field and that was hard to defend against. The climber utilized an interesting 2-part climbing mechanism in order to ascend the bars, and this way of doing things made it possible for them to not just climb high, but climb fast, with an end-of-season in-game time of just 7 seconds. These 2 specific subsystems of this robot are what give it the edge and put it above many other robots that had the same goals. This robot is a good combination of new and old, and it is clear to see how it's able to do so well in the 2021 FRC season.